All right, greetings everybody from Marco Island. We are at the IMC and I'm here, the CEO and founder of Nanoprecise Solution. Welcome, Sunil.
Thank you, it's my pleasure.
Great. Now, you have a session scheduled for tomorrow talking on the impact of energy on the maintenance for manufacturing. Maybe talk a little bit about how does this offer, what is it first off, and how does it offer a competitive advantage?
Yes, it's a great question, and why we are driving towards energy-centered maintenance from reliability-centered maintenance is what everybody knows about. So I would like to use a very simple analogy that think about what's the most complicated machine in this world. It's the human body, right? How do we do the analysis for a human body? The perfect analysis is if you have something that can analyze what are the daily food habits, sleep habits, and like drinking habits. Based on that, you can tell if they are doing it properly so that they never get a cancer in the first place, right? Rather than having a system which says, oh, it seems like you have an early stage cancer now, right? Which one is better? Definitely the first one. So energy-centered maintenance is basically like that. Instead of telling the customers, telling the users, that there is something wrong now which is too late, we are telling, okay, there seems to be a certain component inside your machine which has some issue, which is because of which it is causing more energy. So what it does is it basically is way more early in the diagnosis, and it also gives them incentive that I need to do a maintenance either now or maybe 3 months later. Why don't I do it now? Because right now it is costing me on this pump around $500 per month extra, right? So it gives them that incentive by preponing the maintenance action, which has to be done anyways. You are saving energy. This is what energy-centered maintenance is all about.
Thank you. So it's like having an Oura ring and a smartwatch all on for your plant.
Absolutely.
Got it. Thank you for that. Maybe tap a little bit on some of the real use cases that your organization has seen so far.
Yeah. So first of all, actually, we wanted to understand how we can determine exactly what energy consumption increase is coming from, which fault it is coming from, and how do we correlate reliability issues with the energy, right? Mm-hmm. So for that, first we needed to have a sensor in the place. So just the vibration or acoustic does not help here. You need to be able to capture, and current sensor is good, but the problem is current sensor is not at the plug, at the outset. It doesn't give, it just gives the overall power consumption up and down, but it doesn't give very specific to the machine. So that's where we recognize that magnetic flux on the motor, because motor is what drives the machines. Ultimately, like pumps or compressors, everything is driven by motor, and motor runs on the principle of spinning magnetic field. So having a magnetic flux really helps with that kind of analysis. And then we added things like, if there is a problem, any specific component, like a bearing has a problem or a gear has a problem, what's the increase in percentage magnetic flux? Because what we saw is the magnetic flux reading is directly proportional to the increase or decrease in energy consumption of the motor. So we correlate the vibration or any other issues with any other component and see how it is increasing the magnetic flux immediately. And based on that, we are able to find out, and what we saw is that for some of the customers, we saw around 15% increase in energy consumption because of a bearing problem. And especially at a lower speed machine, they keep running with that for months. So basically you're talking about, for one customer, we saved almost potential $40,000 in energy savings, and downtime losses, that is on top of it, because you took action so early that you get downtime saving anyways, plus the energy savings of the next 6 months that you will run that equipment inefficiently because of that maintenance requirement. So in a simple way, our technology provides ROI to the customer in just 1 or 2 diagnosis attempts, on any machinery that is more than 30 to 40 horsepower or more, right? So it's a very high ROI when you add energy on top of downtime.
The downtime currently,
Yeah.
So I get it. Integrating energy management with routine maintenance, but it does require a mindset shift. I know when I went to a Aura ring, to use your analogy, it took me some time, but it makes me aware of things.
Yes.
What are some of the recommendation that you recommend to help manufacturing adopt this ECM?
Yes, exactly. And this is what everybody's asking, right? Like, okay, you tell me there is a problem, and I can run with that. For example, like your car, you know that you need to do an oil change, okay? But let's be honest, every one of us postpone that, because we know if we postpone it by 1,000 kilometers, the car is not going to fall flat. It will still keep running. So that we not having an incentive or a repercussion of it is, devoiding us of taking an action. But now imagine if I show on your car dashboard, because of you driving 500 kilometers extra in the last week with like a not so good quality oil, because you didn't change the oil, your mileage has decreased, that it is costing you $30 per week extra. And I show that on your dashboard. Next time you go to a coffee shop, it will click, oh, I'm wasting $30 per week. Why don't I do this now, right? So incentivizing and gamifying with energy can change, because all we are doing is preponing that maintenance action, right? Like we are still using vibration analysis, acoustic, and reliability to tell what is the problem, but just preponing that early enough and using energy as an incentive, saying that if you take an action now, the energy savings that you get will pay for your maintenance work order, and apart from having a downtime avoided, right?
So gamification, I like that. Does your system provide some suggestions of what gamification should look like as you're adopting the tools?
Absolutely.
Okay,
so we follow a 5-step process. Like we first detect if there's any anomaly, right? The next step, what is that anomaly alludes to? Because if it is a process upset or a process fluctuation, which is a normal thing, but if it is a fault, like an electrical fault, mechanical fault, or a structural fault, that's the next step that we do, fault diagnosis. And then the third step is remaining time to failure due to that fault. And the fourth step is what sets us apart, is what's the increase in energy consumption due to that fault, and what's the root cause and associated action. So you may have a bearing problem, but the root cause may be lubrication, not having adequate lubricant, not having a misalignment, shaft misaligned. There can be 7 or 8 problems and root causes, and every root cause has an associated maintenance action. So unless you tell this fault is causing this much energy increase, in 15% increase in energy consumption, and the root cause is lubrication, and you lubricate it at this time with this particular fluid, right? That's the level of detail you need along with the energy increase, because just saying you're like a problem and saying, oh, you're losing so much money is not enough. You need to also tell the action. Yeah.
Got it. Thank you for that. Both examples that you provided hit home for me personally. So I want to maybe put your cap on the future and think, where do you see this ECM going in the next 5 to 10 years, particularly as manufacturing balance operational goals with increasing environmental regulations and pressures?
Absolutely. And the best part about energy savings is that it is valid for every single machinery in every sector, irrespective of its size, right? Because for the reliability, almost 80% of assets in any given plant are non-production critical. If one goes down, there is a redundancy in place. So really, you're not saving anything by telling up front. But with energy savings, what we have seen, as long as it is beyond 20 horsepower machine, you save enough to justify the requirement of continuous monitoring, right? So what I see is that the future is all about, prescribing maintenance on a right equipment at right time on the right machine that is incentivized from energy consumption, right? And and that will take a precedence because, downtime becomes an automatic add-on because of that, right? You're changing your whole lifestyle so that you never get a cancer in the first place. So that is a much powerful thing rather than having to, which insurance provider you have so that I'm better prepared if I have something, right? So I see a lot of scope for this. And in fact, opening up a lot of new market possibilities. Even those sectors which were had a lot of redundancy in place, now even they would love to do this because they can see a tangible ROI in terms of energy savings.
Got it. Thank you for sharing the insights. And certainly if you're here in Marco Island, join the session tomorrow. I think it's also recorded, so maybe in the next few weeks it will become available. If you have questions for Sunil or his team, feel free to leverage the hashtag on the screen and we'll get the appropriate person to respond to you, or Sunil or somebody else. And look forward to more updates from Nanoprecise.
Thank you so much. It was my pleasure.